Today we will start the chapter D and F block elements. As we have seen in P block elements, the position of D and F block elements is in between S and P block. So let's begin with that only. See, in this periodic table we have first and second group as S block elements. We have P block from 13th to 18th group, and in between these two from 3rd to 12th group we have the D block elements. They are termed as D block elements because their last electron enters in D subshell. So there are 4 series of D block elements, 1, 2, 3 and 4, that is 3D, 4D, 5D and 6D series. And since they are in between S and P block elements, their position is in between S and P block elements, they are also termed as transition elements. As well, their properties are also intermediate to those of S and P block elements. So that is why they are transition elements. Now, within the transition elements, there are 2 series of F block elements which starts from lanthanoid and actinoid but are placed separately below the periodic table as lanthanoids and actinoids. So these are F block elements and their position is in between the D block elements. That is why these are known as inner transition elements. So D block are transition elements and F block is inner transition elements. In F we have 7 orbitals, so there are 14 electrons. So filling of electrons takes place from 1 to 14 in this series. And in D block we have 5 orbitals. D subshell we have 5 orbitals. So we have 10 electrons. From 1 to 10 filling takes place. There are 10 groups. So we'll study about these, the properties and other things about D and F block elements. See, the transition elements. The D block comprises 3 complete rows of 10 elements as told earlier. 3 complete rows, this 1, 2 and 3 complete rows, and last is incomplete, means some of the elements are not yet discovered. So 3D, 4D and 5D are complete series. These are the 3 series also known as first, second and third transition series. Here you see that this space is empty here. This is actually of lanthanum and this space is actually of actinium. Since they have properties similar to those of lanthanoids and actinoids, they are placed along with the series here. So lanthanum and actinium, these are actually D block elements. After the element, after one electron enters the D orbital in these elements, F orbitals starts from 1 to 14. That is from cerium to lutetium in first series, lanthanoid series, and from thorium to lawrencium in the second series. So we'll study the properties. Let's begin with the general configuration of D block and F block elements. The general configuration of D block elements is N-1 D 1 to 10 and NS 1 to 2. Here the last electron goes in the penultimate shell, that is D subshell. N-1 is the last but one shell, that is the penultimate shell. So for F electrons we have 3 incompletely filled shells, means last shell configuration is of last 3 shells. General configuration has 3 orbits, that is N-2 F 1 to 14, N-1 D 0 to 1 and NS 2. So for lanthanoids and for actinoids we have 4F and 5F subshell. So For lanthanoids it is 4F, and for actinoids it is 5F. Similarly, for lanthanoids we have 5D and 6S, and here we have 6D and 7S. That is for lanthanoids and actinoids. We can write here lanthanoids and actinoids. If you have to write the general configuration for these, we can write 4F 1 to 14, 5D 0 to 1, and 6S 2. Similarly, for actinoids, we have 5F 1 to 14, 6D 0 or 1, and 7S 2. Now see the general configuration, see the electronic configuration of some d block elements. That is the first series. This you have to learn from atomic number 21 to 30. You have to learn the atomic numbers from scandium to zinc, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So this series you have to learn with their atomic numbers and electronic configurations. General configuration you all know, it is n-1 d 1 to 10 and ns 1 to 2. P subshell is filled up to argon, that is 18 electrons are completely filled, and after 18 in scandium we have 3 electrons, 2 goes in s and then 1 in d. Last electron goes to s orbitals. S orbital is filled earlier, and then 4s is filled earlier, and then 3d is filled. This you know, the Aufbau principle. You can see here the units place of their atomic number is the number of electron present in d subshell. It is the case with all the elements except chromium and copper, which have extraordinary configuration due to extra stability of completely half-filled and fully filled orbitals. As you already know that one electron from s orbital jumps inside to make the d orbital half-filled, and here to make it completely filled, it jumps from s orbital. So these special configurations you need to remember by heart, and others also. So 3d1 4s2, argon 3d1 4s2 for scandium, then argon 3d2 4s2 for titanium. Now some children do a mistake here, they write 4s2 and 3d1. You have to follow the sequence 1 2 3 4. This is the proper way of writing, though s is filled earlier. But if you have to make ions of these, the last electron from s orbital is taken out. So that is the mistake children do. They write 3d after 4s, and while making the ions they take out electron from the d subshell. So this is wrong. You must learn this way of writing the proper electronic configuration. Thank you for this, and in next we will study about other properties.